Hi everyone, welcome to Mr. Wagged's math class. Last lesson, we talked about similar figures and how our similar figures have the same shape but not necessarily the same size, just like this red rectangle and the blue rectangle. And we also talked about how can we prove two figures are similar mathematically, and the only way to prove that if we can prove that all corresponding side lengths are proportional and all angles are congruent. Today's lesson, we will be talking about the perimeters and areas of similar figures. And the question is, how do changes in dimensions of similar figures affect the perimeters and areas of the figures? Such as, here's the red rectangle, that's 1 by 2, and the blue one is 2 by 4. So the ratio of side length is 1 to 2. Just like 2 to 4 is the same thing as 1 to 2 when you simplify that. So now let's look at the red rectangle that is 1 by 2, and that's the original rectangle. And you can see this is 1 unit by 2 units. And fill out this table and see what happens to the perimeter and the area when you double the dimension and when you triple the dimension to find the relationship. So the first time we will double the dimension, so we're going to multiply each side by 2. And the second time we're going to triple the dimension, which means we need to multiply each side by 3 to come up with the new or similar figure and find the perimeter and the area. Now let's talk about perimeter. Perimeter is the outside of the shape. So if you want to bring a fence and fence this shape, how long of a fence do you need? So you add up all the sides to find the perimeter. But if you're finding the area, that means how many square tiles do you need to fill the floor, the inside of that shape? So you multiply the length times width. Now let's look at this table and find the perimeter of the original figure. Add up all the sides. This side is 1 plus 1 and 2 plus 2 gives you 6. And the area is multiplying the length times width. So multiply the length times width. 1 times 2 equals 2. So the area is 2 and the perimeter is 6. Now double the dimension. That means the length is 2 now and the width is 4. What is the perimeter? Again, the perimeter is add up all the sides. 2 plus 2 and 4 plus 4 gives you 12. And the area is the inside, which is length times width. 2 times 4 equals 8. Now, what if you triple the side length? That means now you have 3 by 6. What is the perimeter? Add up all the sides. 3 plus 3 and 6 plus 6 gives you 18. And the inside, which means the area, length times width, 3 times 6 equals 18. Now we found the perimeter and the area of similar figures. Now let's find the relationship between the original and the similar figures, perimeter and area. What happened? When you double the dimension, how many times bigger the perimeter was from 6 to 12? It's 2 times bigger. And when you triple the side length, what happened to the perimeter? What's the relationship between the 18 and the 6? How many times bigger 18 than 6? It's 3 times bigger because 6 times 3 equals 18. So when you double the dimension, the perimeter doubled. When you triple the dimension, the perimeter also tripled. Now let's talk about the areas. What is the relationship between the area of the similar figure and the original one? When you double the side length, the area is 8. How many times bigger 8 than 2? It's 4 times bigger, not 2 times bigger, because when you double, it's 2 times. But the area now it's 4 times bigger, which is the same as 2 squared equals 4. What about when you triple the dimension? What happened to the area? From 2 to 18, how many times bigger is that? That's 9 times bigger, which means 3 squared, because triple means 3. But if I square that, it gives you 9. So now we can conclude that the perimeters of similar figures, when two figures are similar, the ratio of the perimeters equals the ratio of the side length. When you double the side length, the perimeter double. When you triple the side length, the perimeter triple also. So the ratio also changes the same way. So set up your ratio however you want it to. Small to big to small, red to blue, A to B. It doesn't matter as long as you stick with whatever ratio you chose. So the perimeter of figure A to the perimeter of figure B, that's a ratio, equal to the side length of A to the side length of B. Those are equal ratios. Now areas of similar figures. When two figures are similar, the ratio of the areas equal the ratio of the side length, but squared this time. So set up your ratio again. The area of the figure A divided by the area of figure B equals to the side length of A over the side length of B, and that's how we set up ratio. But this time you have to put it in parentheses and square it. Now let's solve this example. The two figures are similar. Find the ratios red to blue of the perimeters and of the areas. So we know how to set up the ratio now. It's red to blue as a fraction. They only gave us the corresponding side of the 11 for the red and 6 for the blue. Set up your ratio, perimeter ratio, equal the side length ratio. So the ratio of the perimeter equal the side length of the red divided by the side length of the blue, so 11 over 6. Now we need to find the ratio of areas. So set up your ratio, red to blue for the area, equal the side length red to blue, but this time you need to square it because it's an area. So the ratio of the areas equal 11 over 6, put it in parentheses and then square it, which means you need to square the 11, square the 6, which means 11 times 11 and 6 times 6. You end up with 121 over 36. And the last example for today is a real world problem. A swimming pool is similar in shape to a volleyball court. Find the perimeter P and the area A of the pool. There's no way you can find the perimeter and the area of the pool by itself because you only have one side length, which is 18 yards. I don't have the other side to add up all the sides to find the perimeter or to multiply length times width to find the area. So we use similar figures. Look at the volleyball court. They gave you the perimeter and they gave you the area and they gave you one side length. So to find the perimeter, set up your ratio, and we're going to set up the ratio court to pool. So the perimeter of the court divided by the perimeter of the pool equal to the width of the court divided by the width of the pool. Now substitute these numbers, 6 over P, I don't know what it is, which is the perimeter of the swimming pool, equals to 10 over 18. Since it's a proportion, I can cross multiply. 18 times 60 is 1080 and 10 times P is 10P. Now solve for P, which means divide both sides by 10. You end up with P equals 108 yards. Now the area. Set up your ratio first. Area of the court to the pool equals to the width of the court and the width of the pool, but this time it's squared because it's an area. And remember to square the numbers first. So the area of the court is 200 divided by A, I don't know what A is, which is the area of the swimming pool, equals the side length of the court 10 over the side length of the pool, which is 18, but now you need to square it. So now bring 200 over A down, equals 10 squared is 100, and 18 squared is 324. So remember to square first. Now cross multiply. 324 times 200 is 64,800 equals 100 times A is 100A. Now divide both sides by 100. You end up with A, which is the area, 648 yards squared. And that's why we need similar figures to find missing information. That's it for today's lesson. Thank you for listening.